The life cycle of stars. Stars are formed from clouds of dust and gas collapsing under gravity, and that's a bit like squeezing a gas. So the gas gets hot, and as the temperature rises, it forms a protostar. Once it rises enough, once it's been squeezed enough, nuclear fusion begins, and so you get this outward pressure from the fusion which balances the inward pull of gravity, which was causing the cloud of dust and gas to collapse, and there you have a stable star, which is where our sun is at the moment. Stars form galaxies, groups of stars, literally cities of stars. Each galaxy has a huge number of stars in it, and there could be a billion galaxies in the universe. Our galaxy is about 100,000 light years across. 1 light year is the distance travelled by light in 1 year. Given that light can travel round the Earth 7 times in a second, that's a very, very long way. So, the distance between one star and the next in our galaxy, our next nearest star, is about 3 light years away after the sun. So it takes light 8 minutes to get from the sun to us, and it takes about 3 years for the light to get from the next nearest star to us. So galaxies are very big. So when the star gets to that stable phase, it is called a main sequence star, and all stars will go through this stage. What happens next depends on the size of the star. So here you have this balancing of the inward pull of gravity and the outward force due to the fusion going on, releasing all that energy. But when the hydrogen starts to run out, the fusion falters. The fusion is reduced. That causes the star to collapse. What happens next then depends on the mass of the star. If the star is a small star like the sun, then you'll get a red giant. That is to say, it expands and cools and becomes very big. In the case of the sun, when the sun goes into its red giant phase, the Earth will be inside the red giant. So when we say giant, we mean very, very big. So it expands and cools. If it's a big star, then it's a red supergiant. So it's very, 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 very big. One of these small stars, like the sun, when the fusion falters and the hydrogen begins to run out, the star collapses, fusion begins, different fusion reactions begin, and the star expands and cools into a red giant. Throwing off that outer layer then leaves behind the core, and the core is a white dwarf in this case. White because it's shining brightly, dwarf because it's not very big. It will cool down, of course, and then become a black dwarf. Larger stars, they go through that red supergiant phase, and then the collapse produces a supernova, the most enormous explosion, and that leaves behind a neutron star. Now, the neutron star has a density of around 10 to the 17 kilograms per meter cubed. Now, to compare that with the Earth, that's about 5,500 kilograms per meter cubed. If you took an average lump of Earth, that's what you would get. So to give you some idea of what that means, if you had a 1 litre bottle of water, that is a mass of a kilogram. If you filled that 1 litre bottle with neutron star material, that would be 100 billion tons. That's an enormous number. To try to give you a picture of what that means, that's about 50 times greater than the mass of all the cars on the Earth combined. So neutron stars are incredibly dense. If it's a very big star, then you have that red supergiant supernova, but what's left behind is a black hole. Now it's a black hole, we call it a black hole, because it is so dense that even light can't escape the gravitational pull, hence the black. The density at the center of a black hole is technically infinite. So if you take a small black hole and you look at the density on the surface of that, it's about 1,000,000 times more dense than a neutron star, which, as we've already established, is very, very dense. The final thing I wanted to say was in terms of where elements with a mass greater than iron come from. Elements up to iron are made during those usual fusion reactions in your star. All stars, small stars, will do this. But beyond iron requires the conditions of a supernova. So it is only those larger stars that go through supernova that can make elements like gold, for example, but elements that are heavier than iron.